in some of the last problems, we had you multiply something like this. 2x minus 3 times 5x plus 4 times 7x minus 2, or something like that. And said just write down the first and the last problems. So we times it out, and we had 2x times 5x is 10x times 7x is 70x cubed. And then there are some middle terms in the middle, and then we had negative 3 times positive 4 times negative 2, which gives us a plus 24. Now the reason we had you do that, it just wasn't a fun exercise, but was that you can start with a polynomial and go backwards and try to get some of its possible rational roots. So what we're going to talk about today is called the rational zeros theorem. Now this rational zeros theorem is just about saying what is possible and what is not. I'll show you what I mean. Let's take an example of, I'm just going to make one up. We have something like 10x cubed plus 15x squared minus 3x plus 4. So this right here, when you just look at it and somebody says, oh, can you solve that? Can you give me a 0? Or if this is a function, a graph, can you tell me where the x-intercepts are, the x numbers that'll get me 0 popping out? You're like, they could be anywhere. You have no idea. They could be all over the place. Well, this rational zeros theorem says, no, actually, they couldn't be just anywhere. If they are fractions, now mind you, they could be imaginary or have square roots or something, but if they are fractions, there is a restriction on them. If this thing factors, so that's a big if, but if it factors, it's going to have to factor into something where these guys, let me highlight these areas, that guy times that guy times that guy has to multiply up to 10. Let's write down a few different options just of what the first ones could be. So we're going to write down some options that could times together to be 10. We could have x times 10x. We could have an x and a 2x and a 5x. Or they could be, a 2x, a 5x, and a 10x. I'll write down just this other one. A 10x and an x and an x. So that's actually the same one as up here, but when I show you what the other one is. Now, look at this guy. There are only certain numbers that will multiply to 4. You'll notice we cannot ever put a 7 there, or a 13. These will not multiply up to 4. So let's get those guys out of there and put in some numbers that are possible. We might have like a +1 and a +1 and a +4 here. Or just so you can see kind of the difference here, we might have a -2 and a -2 and a +1. That would times up to 4. Now the point of this activity, taking these and going to here, is so you could see the connection between the individual factors and the first and the last. So here you can kind of see these numbers in purple have to multiply up to give you 4, and the numbers in light blue have to multiply to give you that 10x cubed. So let's write down one other way. We could have a +1 and a -4 and a -1. Now notice, if we were to solve these, just these different possibilities, this would give us x equals a -1, and x equals a -1, and x equals, what is that, a -4/10 as a possibility. Or if we were to solve this guy, we'd get an x equals a -1, and x equals +4/2. I'm going to write it like that. That is simplified to 2. Or we could have gotten an x equal 1/5. And then the bottom one here, x equals a +2/10, just a +2, or x equals a -1. So all these are different possibilities just based on the clues given in the first and the last term. Now we see what the zeros are. Notice that this limits the possible zeros. What are the possible zeros? Well, we're going to stay, what are the possible ones that are fractions? Possible zeros. This is the big question. They could be any fraction out there, except now we know, no. You might have x plus any factors of here. So you might have a plus or minus 1, a plus or minus 2, or a plus or minus 4. Just because you might have something like this with a 1, a 2, or a 4 with a plus or minus in here. The other options are you could have a plus or minus 1/5 or 1/2 or 1/10. So let's write that down. You could have a plus or minus 1/5, 1/2, or a 1/10 there. You could have a plus or minus 2 with a 5. So you could have a 2 there and a 5 there, or a 2 there and a 5 there. So all the factors of 10 could be denominators. So you could have a 2/5, 2 2s, or a 2/10. These guys are already taken care of, so we're not going to include those. And all of these are plus or minus. Or you could have a plus or minus 4/5, or 4/2, which is already there, or a 4/10, which is already up there. So out of all the millions and billions of fractions out there in the world, those are the only ones that are possible to be a zero on this particular polynomial. That's what the rational zeros theorem says. Is you take all the factors of the last term, write them down, and then all the factors of this one over any of the factors of the initial coefficient, and those are the only possible fractions you can have. Look, no sevenths, no sixths, no thirds, because of the setup of those two numbers. Okay, let's try another one. 6x to the 7th plus some blah, 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 plus 10. And we're going to try to find all the possible fractional zeros of here. So this is how you do it. You say, ooh, let's not worry about all the factoring. I know I can go plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. Great. And the factors of this are a 1, 2, a 3, and a 6. So in addition to these, because we could have x plus 1, x minus 1, x plus 2, x minus 2, x plus 5, x minus 5 to give us an x plus 10, x minus 10 to get these. Now these could be leading coefficients, so we have to take all of these over those. So we might end up with a plus or minus 1/2, plus or minus 1/3, plus or minus 1/6. Plus or minus 2/2, plus or minus 2/3, plus or minus 2/6. Oh look, those guys are already accounted for right there, and 2 over 2 is 1. So plus or minus 5/2, plus or minus 5/3, plus or minus 5/6. And then plus or minus 10/2. Oh, we already got him there. Plus or minus 10/3, and plus or minus 10/6, which is 5/3, already have him up there. So those are the only numbers that could possibly be zeros of any polynomial with a 6 at the beginning and a 10 at the end, depending on what the middle terms are. None of these may work, but if a fraction is going to work, it must come from this set, and that's what the rational zeros theorem is all about. Most of you will have calculators, and you'll be able to pull out one of these using a calculate function or a solve function or a table and to see which one it is. But if you're being tested on the rational zeros theorem itself, this is what it says, is that between that term and that term, these are the only possible values.